Hi guys, today I'm going to go through the COS3711 past paper for October-November 2022. Sorry, my mouse is a bit jumpy. By way of introduction, I'm just going to go through a checklist of some sensible suggestions on how to approach your exam paper, but just a few things that you should be aware of or should do is: one, check that you have Iris installed and that it's working, and do that prior to the exam. It's not something you want to fiddle around with on exam day. Just remember, your exam script will not be marked if you do not use Iris during the exam. Secondly, know where and how to access your exam script. I know that's obvious, but you'd be surprised that students sometimes don't do that or aren't aware of it, and then they battle to find the script and waste exam time. Thirdly, read the instructions carefully. The instructions on the exam scripts are quite long. Most of the instructions are fairly obvious stuff, but just read it carefully and make sure you know exactly what to do. For example, the instructions include things like submitting in PDF format. Make sure you do that and not some other format. Also, there's an honesty declaration that you have to complete and submit. Make sure that you do that. But just take a minute, 2 or 3 at the beginning to read the instructions very carefully. Don't just rush into it. Then 4 and 5 together. Check the mark allocation and draw up a schedule based on the marks for each question. The exam scripts are usually 80 marks, which means that you need to do about 20 marks worth of work every 30 minutes. Just allocate your time wisely and do not waste time on questions with a very low mark allocation. One of the biggest problems with the COS3711 exam is that students run out of time to finish the exam. So draw up a schedule based on the mark allocation for each question and make sure you stick to it. If you're struggling with the question and you're running out of time, rather leave it and carry on with the next question, because you're more likely to get marks starting a new question than you are trying to finish off a question that you're struggling with. The COS3711 exam will have some kind of a scenario at the beginning of the exam which you need to read carefully. Sometimes by way of text, sometimes it's a UML diagram, and there have been occasions, although it's less frequent, where it's a code example. But make sure you read that and understand that scenario very carefully, because all the questions that follow are based on it. If you don't understand that scenario or misread it, you're going to struggle to answer the questions that follow. And point 7, just remember there's over 500 students in the class, and the marker needs to go through 500 scripts. Do not make it difficult for the marker. They don't want to sit there trying to figure out which question you're answering. Number your answers clearly. Do things like ruling off after each question. Leave space between lines and so on. Don't cramp things up. Make it as neat and tidy as you can and easy to mark as possible. For those of you who will be using a word processor during the exam, it might be an idea to prepare a blank document with things like your name and student number in it, and the module code and headings, question 1, question 2, question 3, etc. Remember, it's very easy to delete things from a word processor, but it takes more time to put in new entries. So I'd suggest you set up a document ready for your exam. Put as much information in beforehand so you don't waste time during the exam. Then point 8, check that you know how to convert to PDF format prior to the exam. This applies particularly to those of you who will be handwriting your scripts. Make sure you've got a proper app available that you can scan or take a picture of your script, and make sure you can do it legibly and make sure you can get it out of your device into a laptop or a computer in a way such that you can submit that document. But don't leave it until your exam to try and figure out how to convert your exam submission into a PDF format. So those are some generally pretty obvious suggestions, but I think they're worth taking note of. Then looking at the exam script itself, the scenario that's at the beginning, the first paragraph is just some background information on chocolate, which is the main topic of this exam. There's nothing particularly useful in there, it's just background reading. Paragraph 2 is the most important part, and it reads as follows. You may assume the following about designing an application that manages various types of chocolate. It's very important that you read and understand this carefully because it will affect how you answer many of the questions. Initially, it has been decided that chocolates can come in bars and slabs. A user should not be able to create instances of a basic chocolate that is neither a bar nor a slab. Now, there's quite a bit of information in that sentence. It should be apparent immediately that you are dealing with an inheritance hierarchy and that you have a chocolate as a base class and bars and slabs as two derived classes. Then note also, a user should not be able to create instances of a basic chocolate. That means that the chocolate base class is going to be an abstract class. So just be aware of that. That's quite an important aspect for everything that follows. Then the second point, all chocolates have a name in the form of a string and a flag indicating whether it is vegan or not. So there you have two properties for your base class. You have a name and a flag which indicates whether it's vegan or not. That flag at this stage is slightly ambiguous because the flag is often bool, although you can also use a Q string and use the words yes or no, for example. So just bear that in mind. But the scenario doesn't state which you should use, so for the moment either would be acceptable. Then they should also have all, note the word all, have a string representation of their data members. So that means there's going to be a toString method in your base class, and that will also be carried through into the derived classes. Now remember that your chocolate base class needs to be abstract, and the way it would be made abstract is for this toString method to be pure virtual. So that would take care of the abstract aspect. Then you are required to include the number of blocks there are for slab chocolate. So note now one of the derived classes, slab, has an additional data member or property. Next point, each instantiated chocolate should have a unique serial number starting at 1 and incrementing by 1 for each new chocolate instantiated. This should not be managed outside the chocolate class hierarchy. So two things arise from this. Each instantiated chocolate should have a unique serial number, so that's another property that will be part of your base class and will be carried through to all of the derived classes by inheritance. But then you also need some mechanism for keeping track of the current serial number and incrementing it, and that must be done within the chocolate class. So you can't have a separate class that does the counting. The obvious way, and I hope it's obvious, is that your chocolate class needs to have a static data member. Remember, static member belongs to the class and not to individual objects. And that static member will be used to store the current value of the serial number. Next point then, there is a register of chocolates that holds all instantiated chocolate objects. So a register of chocolates, that would mean a list of some sort that stores all of your chocolate objects. And that includes the derived classes as well, of course, or derived objects. And then an appropriate design pattern should be used that allows the user to choose the kind of chocolate to instantiate. So there's two possibilities here. You could be looking at the abstract factory pattern, or the factory method pattern. Now in this scenario we only have one type of product, and that's chocolate. So the abstract factory would be overkill. You only need that if you have multiple types of products. So the appropriate design pattern would quite clearly be the factory method. So we've learned quite a lot from this basic scenario, and as I said before, it's worth spending a bit of time or investing a few minutes in reading it carefully and understanding all of these requirements. So let's move on to the actual question. Right, question 1, 29 marks. That's quite a high mark allocation, so it's worth doing this question well. Considering the scenario given above, draw a partial UML class diagram that captures the scenario. Note, you must read this very carefully. Notice it says partial UML class diagram, so you don't want to waste your time putting in detail that's not actually required. You should include the necessary classes, class attributes, and class relationships that are mentioned in the scenario, including class member access specifiers, that's public, private, or protected. Then you do not have to include the client GUI class nor indicate constructors or other methods in the classes you specify. Please take note of that. Do not waste your time putting in constructors or any kinds of methods. It's not required. Remember, we are looking at a partial UML class diagram. Only include the information that is actually specified here. In a note at the bottom, you may use a software tool to create the UML class diagram and use underlining to represent italics and hand-drawn UML class diagrams. If you are going to use a class diagram, please make sure you're familiar with it beforehand. You know how to use it. You don't want to waste time in the exam trying to figure out how to use it. And I'd also suggest that you possibly draw up a basic document that includes a few classes and an inheritance hierarchy and things like that. If you look through the past papers, you'll see that the diagrams are in fact fairly similar in terms of what they contain. So it might be worthwhile drawing up a blank document, or no, sorry, not a blank document, but a basic document which contains the necessary classes. That will save you time during the exam. Remember, it's very easy to delete things that you do not require. But that's just an idea. Obviously, use whatever method works for you. Then there's one bit of information there that could cause a bit of a problem. Sorry, my mouse is a bit sensitive. Use underlining to represent italics in hand-drawn UML class diagrams. Bear in mind that underlining is normally used to indicate static. Now in this scenario, we have both static and abstract, which requires italics. So you're going to, if you're drawing by hand, you're going to have underlining to represent both abstract and static. I'd suggest you use two different kinds of underlining, say a squiggly line for the static italics and a straight line for static, and maybe just write a little key on the side of your diagram to show which represents which. But just bear in mind that there's two types of underlining that may be required in the UML diagram. Then the method I suggest to approach a scenario like this in preparing the UML diagram is to draw up a table like this with 4 columns, which shows the classes, the relationships, the methods, and the properties. And then you can just detail each of the items and use that as the basis for your diagram. If you are going to use this method, I'd suggest you draw up a table like this before the exam and have it ready. So you don't have to waste time drawing up the actual table during your exam. Just take note here that I have included the methods in this table. It just makes it a bit clearer for me. But remember, the instructions or the scenario say that you do not need to include the methods and the constructors. So the classes we identified, right? We identified the chocolate class, which is required to be abstract, and that's the base class for inheritance. Then it has a pure virtual toString method, which is what makes it abstract. Then the properties that were identified that all objects need to have is the name, which is a QString, then a flag to keep track of whether it's vegan or not. I've put QString here, but that could conceivably be bool as well. Then every object also has to have a unique serial number, which would be integer. Remember, your derived classes will get these properties by inheritance. And then you also need something to keep track of the current value of the serial number. So I've included a property called count, which is static, and I've also shown that by underlining. Then you have two derived classes for your types of chocolate that you can instantiate. That's a bar and a slab. The relationship for both of them is obviously inheritance. Then they both will contain the toString method, which is virtual in the base class, and they'll be implemented using polymorphism. Then your slab class, the derived class, has an additional property. You have to keep track of the number of blocks, which would also be integer. Then the scenario said you need a register of all the chocolates that are instantiated. That would mean a chocolate list, and that can be done either by way of composition. In other words, you can have a class that contains or is composed of a list, or you can use inheritance, whereby your chocolate list inherits Q list. Both of those solutions would be acceptable. Then the relationship of the chocolate list class to the chocolate base class would be aggregation or composition. I'll discuss that in more detail, but your chocolate list contains or is composed of chocolates. So that would indicate aggregation or composition. Then the design pattern that had to be used to instantiate your types of chocolates would be the factory method. So you'd have a chocolate factory, and your relationships would be that your chocolate factory uses chocolate. It obviously has to instantiate chocolate objects or derived objects as well. And then it's also used to create the two different types of chocolate, the bar slabs. That would also have to by creates chocolates. Again, this method, create chocolate method, I've shown you is not actually required. You don't need it in the UML diagram. And we'll look at that a bit later, but you notice the two types of derived classes have a different number of properties, and you need to be able to handle that. And the way I've done that is by having a default parameter, which means that you can call that method with or without that fourth parameter, but we'll look at that in more detail later. Then the actual diagram, I suggest you step through that using the information that you've prepared in the table. And the first step would be to draw each class with its relationships, methods, and properties. Bear in mind that's a general statement. For this specific paper, you do not need to include the methods. So our base class is chocolate. And so we have our chocolate class. Note the italics, it's abstract. Then it has the properties that we identified. Notice I've indicated that they're protected. Bear in mind that this is an abstract base class that's used for inheritance. Those properties need to be accessible in the derived classes. If you make them private, they will not be accessible in the derived classes. So those three properties need to be protected. And then it has the private count property, which is static, and that's used to keep track of the current value of the unique serial number. Then I've shown the pure virtual toString method here just for clarity, but again, that's not actually required for this solution, so you can leave that out. In the next step, continuing drawing the classes, we then add the derived classes to our chocolate base class. So we have the bar and the slab, and you notice that the slab has the additional private property to keep track of the number of blocks. And we've indicated inheritance using the appropriate open arrowhead, and it's a good idea to also write in what the actual relationship is that you're using, in this case inheritance. It just makes it very clear of what you intend showing, and there's always the possibility that you end up using the wrong type of arrow and you would lose marks, whereas if you write in what the relationship is, then it's absolutely clear of what you're doing. So I'd suggest you do that as well. You might recall from solutions that Dr. Pilkington did for assignments, he also always wrote in or included what the actual relationship was. So that is a fairly simple addition. Then step 3 would be to add the next class, which would be the chocolate factory. Again, I know it's getting a bit repetitive, but you don't need to actually include that method. It was specifically stated. So chocolate factory uses chocolate because it needs to instantiate chocolate objects. So it uses a pointer to chocolate objects. This is what it returns. So it uses the chocolate class, and then it also creates the derived classes of bar and slab. So that's the chocolate factory with the relationships. It uses chocolates and it creates bar and slab objects. So far, so good. And the last step then is to add the register or chocolate list. As I said before, that chocolate list can be a list either by inheritance or composition. I've shown it here with composition. In other words, it has a list, it contains a list. You could also show that by inheritance from QList. Then chocolate list has chocolates, or contains, or is composed of chocolates. So the relationship I've shown here is aggregation, because there is no indication in the scenario that the chocolate list class is responsible for the life cycle of chocolates. So that would indicate aggregation. Another way of looking at it is that can a chocolate exist separately and apart from the chocolate list? And the answer to that is yes, of course. So again, that indicates aggregation. But there's another way of looking at it. Because our list is made up of a list of pointers, when the chocolate list object is destroyed, it would need to call delete on all the chocolate pointers in its list. Otherwise you will have a memory leak. So in that sense, then the chocolate list becomes responsible for the life cycle of the chocolate objects, and that would in fact be composition. So as far as the relationship for this specific example is concerned, you could use either composition or aggregation. If you're in doubt, just use aggregation. It's generally the safer bet. So unless you get specific mention in the scenario that the chocolate list is responsible for the life cycle of the chocolate objects. So aggregation is probably the better answer, but composition would also be acceptable. And there's easy, I think, 14 marks for you. At the end of the day, it's a fairly simple and straightforward diagram, very similar to what's been in past papers, just with different names. And question 1.2. Write the class declaration and implementation code for the chocolate class. Include the following requirements when doing so. All requirements from the scenario on page 2, that's the instantiation restrictions, in other words, the abstract class, the string representation that returns the data values in a comma-separated list, right? That's the pure virtual to string method. And then you need to handle the unique serial number. Then another bit of important information, there should be only one constructor that will allow for optional arguments for the data members. So you've got to provide a user-defined constructor that takes arguments, and those arguments must be optional, so you're going to have to use default values. And just bear in mind, this will prevent a default, or will prevent the compiler from implementing a default constructor. So you will always have to call this constructor with arguments, although there's a slight trick to that, because we make them all optional. It can actually be called then without arguments, but bear in mind that it is the user-defined constructor that's being called and not the default constructor provided by the compiler. So the implement or the declaration of our chocolate class would be as follows. We have a public constructor with two arguments or two parameters, and both of them have default values, so it could be called without any arguments. Then an important thing, your destructor, it needs to be virtual. Bear in mind you're dealing with an inheritance hierarchy where you have virtual methods. If you don't make your base class destructor virtual, when derived objects get destroyed, that would mean that the base class destructor is always called, and that could have quite serious implications if you, for example, have specific requirements in your derived objects and you have pointers that you want to delete. Your derived class destructor will never get called if your base class destructor is not virtual. It will always call the base class destructor. So if you have any virtual methods, you must have a virtual destructor. That's actually relatively important. Then, to make our base class abstract, we need a pure virtual method. So we have a virtual toString method, which we make pure virtual by adding that equals 0. So now we've taken care of the base class. Then notice the data members are all protected because they need to be accessible from the derived classes. Do not make those private because it won't work. Then we have one private data member, and that is a static member, which I've called count. You can use any sensible name, and that will keep track of the current value of the unique serial number. Then the value for a specific object of the serial number will be held in that protected data member that I've called serial number. Looking at the implementation, right, you need to initialize your static data member, and remember the way to do that is it has to be initialized outside of the class. Then you need to use the scope resolution operator to specify which class it belongs to. Remember, static data member belongs to a class and not to individual objects in the class. Now it's been initialized to a value of 0. We then have the constructor with two arguments or two parameters. Those parameters get initialized in the initialization section of the constructor. Please, that's where you do initialization. Do not initialize your data members in the body of the constructor. The correct place to do that is in the initialization section. Then within the body of the constructor, we take our count variable, which has been initialized to 0, and we increment it. So the first time the constructor gets called, that count will get incremented and have a value of 1. We then assign that value to our serial number data member, which belongs to the objects, and that will become the current. That current value then becomes the serial number of the object that is being instantiated. Then bear in mind the second time the constructor gets called, your static member retains its value between calls. It will have a current value of 1 when you call the constructor. Gets incremented by 1 again, becomes 2. So the second object that gets instantiated will then have a serial number of 2, and so on. So that is how you handle the unique serial number for each of the objects. You just increment your static data member in the constructor and then assign that current value to each object that's been constructed. We then have our destructor, which doesn't need to do anything specific. Then the toString method. Remember, this is pure virtual. In C++, a pure virtual method, it's optional whether you define it in your source file. You do not have to define it, but you can if you want to. And in this case, we do need to, because these data members are common to all objects by inheritance. So we put all the common code in the base class here. Otherwise, we would have to repeat this code in each and every object, and that would be a bit wasteful. Then in the derived class, we just call this base class implementation of toString and add any additional information we want to. So all the toString method does is just create a string and adds in values for each of the data members. That's the name, the flag, whether it's vegan or not, and the serial number, and then just returns the string. So that's a very straightforward toString method, but as I said, needs to be included in the base class, so you don't have to repeat this identical code in each and every object that's instantiated. Then carrying on, question 1.3, based on the scenario, is chocolate C a valid code? In other words, simply instantiating a chocolate object and calling the constructor without any arguments. Then the port master explain clearly why you say so. The mark is only awarded for the reasoning. So you need to understand what you're doing and why you're doing it. So can you instantiate a chocolate object by calling constructor without arguments? And the answer is no. And in fact, it's got nothing to do with the constructor itself. The answer is no, because chocolate is an abstract class and you cannot instantiate objects of an abstract class. Just emphasize again, the mark is only awarded for the reasoning, not for saying yes or no. So you must be able to explain why you say yes or no. So you need to know that you cannot instantiate an abstract class. In question 1.4, it has been decided to make the chocolate class a Q object simply by inheriting Q object. Then the question is, give one major benefit of making chocolate inherit from Q object. There are several benefits. One is it enables signals and slots. The second one is that it enables reflection, and it also enables threading. Remember, to have a worker object with Q thread, it needs to be a Q object. So any of those would be acceptable, but signals and slots is, I think, the most important one and the obvious answer. So I would suggest the best answer would be signals and slots, but you could also make answer reflection or enabling threading. Question 142. Besides what is given in the scenario before question 1, assume that coverture chocolate inherits from chocolate. Would the following code that passes an instance of coverture chocolate to display function be legal? Explain clearly why you say so. The marks are only awarded for the reasoning. So here you have coveted chocolate, which inherits chocolate, and you instantiate an object. Then you have a display method, and you pass your chocolate or coverture chocolate as an argument to your method call. So is that legal? And the answer is no. The reason why is that you cannot pass a Q object by value. Remember, when you pass an argument by value, you're making a copy. You effectively are calling the copy constructor, which makes a copy of that object, and that is what is passed into the method. You need to know and understand this about QObject, that QObject has no public copy constructor. The copy constructor in QObject is in fact private, but because there is then a user-defined copy constructor, the compiler won't define a default copy constructor. So by providing a private copy constructor, you in fact are preventing the compiler from including a default copy constructor, and that effectively blocks the copy constructor entirely. It's actually a reasonably clever bit of coding, but yeah, the important thing is to remember that Coventry chocolate inherits chocolate, which in this aspect of the scenario inherits QObject. That is explained in detail in the QObject documentation, so I suggest you do read through that if you're not familiar with this. But the answer is you must pass QObjects by reference or by means of a pointer. But you cannot pass a QObject by value because you cannot make a copy of a QObject because the copy constructor is effectively blocked by having a private copy constructor. It's only 2 marks, but it's the kind of detail that you do need to know about. In question 2, 22 marks. Remember, that's about a quarter of your time, so you should allocate yourself approximately 30 minutes for this question. The intention is to scan text files for references to vegan chocolates. This task will be taken on by a class that is to be run as a thread. Then remember about QThread, there's a few things you need to know about running objects in a thread, and the most important one of which is that the object itself must inherit QObject. So you know straight away that you're dealing with a class here that has to inherit QObject. So the actual question, write the class definition of the scan class, which is to be run as a thread. That will be used to count the number of times vegan chocolates is mentioned in a piece of text. The file name to scan will be passed to the class instance. In other words, you've got to pass it in the constructor. And the number of occurrences should be returned to the calling function once the scan is complete. Include all functionality that will be required so that it conforms to best practice. Use function variable names that will make it clear what the purpose of the function or variable is. So the file name you've got to pass to the constructor. Then the number of occurrences should be returned to the calling function when the scan is complete. Remember, when you're dealing with threading, you cannot have a method that simply returns a value. You've got to communicate back to the calling function by means of signals and slots. So you're going to have to define a signal that will return a value to the calling function. Then include all functionality that would be required so that it conforms to best practice. That would involve using the move to thread method and connecting all the appropriate signals and slots besides the item that I've just mentioned before that. So if you know how to use QThread, this is actually a fairly straightforward question. So this is what our scan class would look like. The first thing is that we inherit QObject. Remember, to use threading, to move an object to a thread, it must be a QObject itself. So you must inherit QObject. You must include the QObject macro for it to work properly. Then we have a public constructor which takes the file name or has a file name as a parameter. And just be careful with the standard QObject parent. It may be an idea to in fact not include that. Remember that when you move an object to thread, it cannot have a parent. So if you instantiate your object and give it a parent, your threading won't work. So although it is standard to include this parameter when defining a QObject, you will never actually use it in the scan class, and so it might be an idea just to remove that completely. Then you need a public slot, which I've called count vegan, but any sensible name will do. And this is the slot that will actually do the processing, or at least initiate the processing of the counting process. And just remember, it's this slot that you need to connect to the started signal from your Q thread. So when your thread starts, it will connect to this slot and get the process going, running in the thread. So you have to have a public slot that will initiate the counting process, or where the counting process will be done. Then you need to implement some signals. One I've called return count, which takes an integer parameter. Again, any sensible name would do, but you will emit, when you complete the counting process, you will emit the signal, which will then return the value, and you connect it to an appropriate slot from your calling method. Then you also need to implement a finished signal, which would be the last thing that is processed, and you need to connect that finished signal to the quit slot of your thread, so it tells the thread to stop. And then you also need to connect it to the delete later slot of your thread, so that it gets deleted at the appropriate time. And it also needs to get connected to the delete later slot of the scan class, so it gets deleted. Remember, your Q thread and your worker, the scan class, get implemented as pointers, so you don't want memory leaks. So you use this finish signal both to stop the thread and then to call delete on both the thread and also the scan class itself. So make sure you include that, so you delete everything. And then we have a private data member to store the file name. Remember, it's passed in through the constructor. You store it in a private data member, and this return count method will access the file when it does the actual counting. So that would be the definition of our scan class. And that, as if you've done threading in the assignments, you should be able to do this quite easily. You need to know about inheriting Q object, a public slot, and then defining the signals. Those are the most important aspects of it, but that shouldn't be very difficult at all. In question 2.2, it has been decided to use regular expressions to scan the file. Write the regular expression in quotes that can be used to check for the words vegan chocolate or vegan chocolate plural in the provided text file. You should not use the pipe symbol, and ensure that you use escape characters correctly. Remember, it's specified that it's in quotes, so it's a string, and you therefore need to escape all of your backslashes. There are at least 3 possibilities, there might be more. It's important to start and end with the word boundary, which is sorry about my mouse, which is the \b, which you then need to escape. Remember, it says that you must write a regular expression that can be used to check for words, vegan chocolate. So the words vegan chocolate cannot appear as part of a long string of characters. It must be separate words. So you've got to have the word boundary at the beginning and the end. Then the way that you handle it, including an S or not, is to use the question mark meta character, which is 0 or 1. And there's various ways you can include it, is by putting in the square brackets, which indicates that that question mark numerator applies only to the S. You can also use parentheses, again, that indicates then that the meta character only applies to that S and it's 0 or 1 occurrences. And it in fact works just fine without any brackets. So you have the literal characters vegan chocolate, and then 0 or 1 characters of the S. All 3 of those work, and all 3 would be acceptable. Personally, I think adding the parenthesis is probably the best option, because it then makes it explicitly clear that the numerator applies only to the S, whereas looking at something like we just have the literal characters and the question mark, I think it's quite easy for people to misread that and think that it applies to the complete wording of vegan chocolates. But as said, all three of those are acceptable and all three work. Just a word about regular expressions. I would suggest you prepare yourself for the exam by preparing a cheat sheet which includes all the meta characters for regular expressions. There are plenty of them available on the internet. Look up one and print one out for you to refer to during the exam. But being open book, there's no reason why you shouldn't get basically full marks for the questions on regular expressions. As long as you understand how they work, and if you've got the cheat sheet, it should be guaranteed marks. In question 2.3, the following code stub is used to scan a list of files and collect the data returned from the scanning process. So you have a string list, which is called list of files. Then it loops through that list of files and using threading to scan the files, as we saw in the previous questions. And you collect the number of mentions in a queue list integer, which is named count. So we've got two lists. We've got a list of files and a list of integer counts. Then there's a requirement that this data is be written to an XML file in the following format. We've got a fairly straightforward here with a root tag of file counts. Sorry about my mouse. Then we have a file tag which has a name attribute, and it has a count tag which stores the values for the actual counts, and that is repeated. You'll notice there's actually an error in this XML line format. The closing tags for the file element are missing. Each of those file elements should in fact have a closing tag as well. But if you do this example and prepare it using QDOM document, you will see that it automatically puts in that closing tag. But that is a little omission. Anyway, that's the format that's required, and it's fairly straightforward to do. Then the question continues. Using the partial code given below and assuming that QString list of files and QListInt counts are accessible by this code, complete the code as indicated so that the required XML text above will be generated using DOM. And then you're given a stub of code here. It basically tells you DOM doc, so you know you've got to use QDOM document. Then you've got a QDOM element, which is the root, and some function that you need to create your file counts tag. Then setting up initial variables if required, and then loop through all of them, adding them to the XML text. 11 marks. Again, if you've done your XML and the assignments and understand what you're doing, this shouldn't be very difficult. But let's have a look at the code. Right, the first thing we do is initialize the variables as stated. The first item when using DOM is always a QDOM document. You instantiate your basic document. It needs a root, which is a QDOM element, and you do that by calling the create element method of a QDOM document, and you give it the tag name of file counts, and then you append your root element to the document. This is, the pattern for XML is pretty much the same all the way through. You create an item, whether it's an element or text node or whatever, and then you append it to the appropriate parent. The trick here is to make sure that you append whatever you created to the correct parent. That is where students often go wrong. So your root document gets appended to the DOM document itself. You'll find as you go through then and you create other elements, they then get appended to the root, for example. But just make sure you're very clear on which parent you need to append to. That's one of the biggest mistakes. Then the other variables that we'll need are QDOM elements, because there's two data items we're doing. That's file names and count values. And the count then uses text for the data. So I've created the variables there. You could actually do that within the loop, but it's actually wasteful going through the loop and then instantiating new objects every time you go through the loop. Rather just create your variables beforehand and just give them new variables in the loop. You don't. It's a bit wasteful instantiating new objects on every iteration of the loop. So we then loop through the lists, and bear in mind there's an assumption here that's not actually stated, and that's that both the lists are the same length, because if they aren't, you've probably got a bit of a problem. So we're just using a basic for loop to iterate through our list of file names. The first thing we do then is to create a file tag, again calling the create element method of a QDOM document and giving it the name file. If you look at the sample code, you'll see that the file name has a name attribute which includes the file name. So we then call the set attribute method on the file element. The name of the attribute is name, and it's the value comes from our list of files at the current position. Then the important thing, we then append our file element to the root. As I said before, make sure you get the correct parent. So that takes care of the file element. We've added a tag named file, and we've set an attribute named name, and which has a value from a list of files, and then append that to the root. The next thing we're going to do is create our count element. So once again, we call the create element of the DOM document, give it a name of count. Then this one contains text. So we then call the create text node of the DOM document, and we read the value from the counts list, which remember is integers at the current position. We need it to be a string, so we call the QString number method here, which is a static and used like this to convert that integer value to a string. We then append the value of our count into our count element, and we then append the count element to the file element. Note that the file element is the parent of the count element. And that is basically all you need to do, is loop through and repeat all of that. Then at the end of the day, to actually get your required XML format, you need to call the toString method on your DOM document. I've got return here because this was part of a method in my sample code. You could just as well assign that to a string QString variable, but you do need to show that you convert the DOM document into a string format, because that is how you get the appropriate XML output. So again, if you're familiar with your example from the assignment, this shouldn't be very difficult, but it's the normal XML routine of creating an item such as an element or a text node and then appending them to the appropriate parent and just repeating that. So I don't think there's anything particularly difficult about that question. Then question 3. This is where things change up a bit. Ignoring bars and slabs of chocolate, the chocolate manufacturer wants to have a range of dark milk and white chocolate as subtypes of chocolate. Okay, so what we're doing here is changing the scenario a bit. Instead of having derived classes of bars and slabs, we're now having derived classes of dark milk and white chocolate. And where things get a bit more interesting is these, all three have constructors which have different parameters. So your dark chocolate has a name, a string, the vegan flag, which is also shown here as a string, and then an integer value, whereas your milk chocolate only has two parameters, both strings, and then your white chocolate has three parameters and all three are strings. So we've got to be able to handle these different situations. And then goes on to say that it is required that the following be implemented. One function to create these three types of chocolate. You will recognize that this is the create chocolate method from your factory method design pattern. So you've got to pass the type, then the name, the vegan status, and then the optional third parameter. Remember that optional third parameter can either not exist, or it can be an integer, or it can be a string. So you've got to allow for those three possibilities. Okay, simple question, which design pattern is being suggested here? The answer is obviously the factory method. You can tell that by the create chocolate method. Then write the class definition for the class that would be used to implement this design pattern based on the scenario at the start of this question. So we have a simple chocolate factory which contains the chocolate factory constructor, and then the create chocolate method, which is a little bit more tricky. The first thing, as usual, is it returns a pointer to the objects being created, which in this case is a pointer to the chocolate base class. Then the parameters are QString for the type. You've got to say if it's a milk chocolate or dark chocolate or whatever, so you know which type of object to instantiate. Then you have a QString for the name, which is common to them all. Then you have a QString for the vegan status, which is again common for all. Then taking into account the optional and variable parameter, we've got to handle two different situations here. The one is where it doesn't exist. In other words, there is no third parameter. We handle that by giving it a default value. So if the method call doesn't include that fourth item, it will be given a default value of -1. You can actually use any arbitrary value that would never be a valid value. And then we overcome the problem of it either being a string or an integer by using qvariant, which can take any data type. So we're solving two problems here. We are using qvariant to handle whether it's a string or integer, and we're using a default value of -1, which will never be an acceptable value, to handle the possibility that there is in fact no fourth parameter. And that is when you use, it's not required for this question, but just by way of explanation, when you use that, you would first test qvariant to see whether it is an integer or not. Then if it is an integer, if the value is greater than or equal to 0, then you know it's a dark chocolate. If the value is less than 0, you then know it's a milk chocolate because there is no third parameter. And then the other possibility then is you can check if it's a string, and if it's a string, then you know it's a white chocolate. So that is how you would determine which constructor to call. But that is your definition for your chocolate factory. It's very simple and straightforward, and so the only trick really is knowing how to handle the different possibilities for this additional parameter, and handling whether it's a string or an integer, and also the case where there is no value at all. Question 3.3. The following is a class that maintains a list of types of chocolates created by the create chocolate function. So we have an add chocolate method, And then we have 3 data members using Q maps. It has different ones for dark chocolates, milk chocolates, and white chocolates. So there's 3 different types of Q maps being used for the different chocolate types. Considering the scenario at the start of this paper, answer the following questions. Just remember that the scenario given here, using the different types of dark milk and white chocolates, is actually not exactly the same as the scenario at the beginning. We've changed the derived classes, but we're still using the basic scenario from the beginning of the paper. What parameter would be passed to the add chocolate function? The answer would be a pointer to a chocolate object. Remember, we've used the factory method before, and the factory method returns a base class pointer pointing to the object that's been instantiated. So the parameter that would be passed would be a pointer to the base class chocolate object. Then in the chocolate, this class has only one add chocolate function with one parameter, but 3 lists, one for each kind of chocolate. Without adding any further data members to any of the classes in the chocolate hierarchy, but allowing the chocolate class to inherit from Q object, as in question 1.4, how would you propose the add chocolate function determine which of the 3 lists of chocolate instance past the class should be added? The short answer, and you would need to do more than this, is that you would use Q meta object, which now becomes available because the class inherits Q object, so reflection and Q meta object is available. And how would you do that? Is by using code similar to the following. You have a Q string class name variable, then you get the meta object. Remember, it's got to be constant Q meta objects, and a pointer, and then you call the meta object method of Q object. That's on the C is the pointer to your chocolate object, which inherits Q object. And then you can get the class name then by calling the class name method of the Q meta object. Bear in mind you can actually just chain the class name onto the end of the meta object call there. So that is largely the code that you would be required to answer this question, but I'd suggest you, just for the small number of marks available, you wouldn't be required to add this entire conditional logic, but I'd suggest you add at least the one line, or just write to say that you would then use conditional logic based on the class name to determine which constructor to call. Because I think just getting the meta object class name doesn't fully answer the question. You've got to, I think, indicate that you know what to do with it. But anyway, that is how you would determine which constructor to call, and that's by using Q meta object to get the class name and then doing something sensible with that class name. The question 3.3.3, which piece of data would you use as the key for the dark chocolate Q map, and why do you say so? The reason why would be any unique identifier. You can use anything that will uniquely identify a specific dark chocolate. Remember, each chocolate has a name. Now, there's nothing in the scenario that states that that name is or must be unique. Obviously, it's sensible that it must be unique, but it doesn't say so. So if you do say chocolate name, I would suggest you add a note to the effect that you assume that it's unique. The other possibility that you might remember from the scenario is that each chocolate has a unique serial number. So you could actually also use its serial number, because that would uniquely identify any specific chocolate. So the answer generally, or why you say so, is that there must be any unique identifier that can uniquely identify a specific dark chocolate. And then you can just state your case to say either the chocolate name or the serial number, whichever one you choose. Then 3.3.4, it has been decided that the user should only be able to create one instance of the chocolate list class. Rewrite this class so that this requirement is met using a standard design pattern. Right, creating one instance, we obviously are dealing with the Singleton design pattern here. Considering that we didn't cover the monostate pattern in COS3711, you should remember it from COS2614. It probably wouldn't be wrong to say monostate, but Singleton is obviously the one that this question is aimed at. Okay, then rewrite the class. So, remember you were given some basic code for the chocolate list previously. Okay, rewriting chocolate list as a Singleton. I'm sorry about this jumping, but there's nothing I can do about it. Right, the Singleton design pattern. The first and most important thing is that the constructor is private. For Singleton design pattern, you make the constructor private so it's inaccessible. You cannot instantiate a chocolate list object by calling it constructor because it's just not available. By making it private, you actually are blocking it from being used. Following from that, we then have a data member that stores a pointer to an instance of the chocolate list, and it must be static because we want it to hold its value between calls between objects. And then remember, when you have a static data member, you need a static method to be able to access it. So we then have a static member, which is often called getInstance or sometimes just instance, and that returns a pointer to a chocolate list object. And that basically is what you need for the Singleton design pattern. We obviously then have our add chocolate method as it was before and the data members as before. But the important things are that you have a private constructor, a static data member to hold a pointer to the instance of the chocolate list, then a static method that returns that pointer to the chocolate list object. And that really is all that is required. Again, if you've done your Singleton patterns in assignments, it should be a pretty simple question to answer. Just to emphasize again, the most important aspect is the private constructor and then the static data member and the static method to get the value of that data member. Okay, then question 4. A model view approach can be used to manage and display a list of instantiated chocolate object data. Discuss 3 different general techniques that are open to a Qt programmer to manage and display this data using a model view approach. Explain how the technique would be implemented, mentioning specific Qt classes examples that may be appropriate in the scenario, including what other factors need to be considered when implementing this technique. Okay, the answer to this question is readily available in the Qt documentation, but let's just briefly go through it. Right, the one option is to use the predefined models and views that are available in Qt. Those specific ones are things like QList view, QTable view, and QStringList model, and QStandard item model. And the discussion would be something along the lines of, this is a reasonably flexible approach. Your data is separated from the view, which is the traditional MVC approach. You can use more than one view on the same data, for example, and you can also then use delegates, can be used to modify the appearance of data in the view. So that would be your normal standard use of a model view in Qt, is to use the predefined models and views, which gives you a reasonably flexible approach, and there are several different classes available to do that. Then the next option would be to use abstract models and or views. That's using inheritance based on the abstract base classes. And just remember, you can mix and match here. You can, for example, use an abstract model in a predefined view, or the other way around, an abstract view on a predefined model. You don't have to use inheritance on both the model and the view. Some of the classes available are QAbstract item model, QAbstract list model, QAbstract table model, and QAbstract item view. Some of the reasoning would be, this is the most flexible approach because you can customize your models and views to whatever you want them to do. The downside of this, of course, is that it's by far the most complicated method. It takes quite a bit of effort to use inheritance with models and views. They're not the simplest classes around, but if you want a very flexible, customized approach, then that is what you can do. Then the third option, which to be quite honest is in more cases not the most suitable or easiest to use, you can use the combined model and view, the convenience classes that Qt provides, because more often than not they will actually do exactly what you required. If they don't do exactly what you want, then you can move to the predefined models and views. But what these convenience classes are, they actually break the traditional MVC pattern and they combine the model and view into one convenience widget. The data is actually still sort of kept separate from the view, but they are just put together into one object. So although it's a bit broken, it is in a sense still a model and view implementation. And some of the examples are QList widget, QTable widget, and QTree widget. And the discussion here is that these are by far the easiest to use, that you can just plug them in and use them as they are. There's nothing further to be done. But obviously it's the least flexible approach. It's, take it or leave it. You take what there is and you use it as it is. And as I said, in most cases it actually is all you need. But if you need a bit more than that, then you can move to the predefined models and views. And if you want something really special, then you can go to inheritance and the abstract classes. But that briefly is the kind of discussion you would need on which models and views to use in the different approaches available in Qt. Question 4.2. Suppose there is a GUI class, which is the main user interface, and a MyModelView class that implements the model view approach proposed in this question. If you were to use the memento pattern to set up a backup and restore facility for MyModelView, answer the following questions. Okay, one of my pet hates here is just using this word backup and restore for the memento pattern. Memento pattern is not used for backing up and restoring. It's used for an undo and restore facility is more appropriate wording. So just bear that in mind. Memento pattern is done in memory. It's not a backup writing to file or anything along that line. It's an undo and restore kind of facility. But let's just go with the wording that's provided. Okay, which class would create the memento? The class that creates the memento, it's known as the originator, and in this case is MyModelView. MyModelView, you would implement a create memento method, and that instantiates a chocolate memento object. So that is how the memento would be created. Just bear in mind there's a slight bit of detail. It's actually the caretaker, or in this case the GUI class, which initiates the process. In other words, the caretaker tells the originator to create the memento. The originator, being my model view, would then call the create memento method, which would actually create the memento. So the answer here is originator, which is my model view. Next part of the question, which class would contain the data that is to be backed up? Okay, this wording is actually a bit ambiguous. The data that is actually being backed up is the data that is held in the originator, in the my model view. But remember that the data, when you do this so-called backup process, is actually stored in the memento itself. So to me, it's not very clear whether this question is referring to, should I say, the original data that is going to be backed up, in which case it's held in the originator, which is my model view, or are you referring to the data that is actually backed up, in which case that data is then stored in the memento? And I have an idea this, although I've put originator, my model view here, I have an idea this question is probably expecting the answer of the chocolate memento itself. But just be careful of this wording. It's not very clear whether you're talking about the class that contains the original data or the class that actually stores the data during the actual backup process. So take your pick which one of those it is, and then which class would hold on to the created memento. And that answer is the caretaker, which is your main GUI class. And just remember that that caretaker doesn't have access to the data stored in the memento, so it preserves encapsulation. Only the actual memento object can access the data, and then also the originator, because that's, if you like, the owner of the data. But the caretaker, which actually holds the memento, cannot access the data, and that preserves encapsulation. Then question 4.3, you're given some declarations about a main window and a TCP server and a TCP socket. Reorder the following statements into the order in which they would be performed by TCP server application listening for and processing connections. Remember that connect statements may have limited function scope, so you may assume that you cannot list them all at the start of the application. You may simply write down the numbers of the statements of the correct order. So this question is actually telling you that you cannot, as we'll see, the options include several connect statements. You cannot just write all the connect statements at the beginning, because the way this TP server and socket works is some of the objects don't actually exist until part of the way through the process, so you can't really connect them all beforehand. So let's just look at these options. Right, I'm just going to go through the answer and then look at the options as we go through. So as far as I can work out, the answer would be the following. Option 2 is you connect a push button that's in your GI, and when that is clicked, it then calls a setup method in your main GUI, that setup slot in your main GUI. The next one that would then be item 3, which connects your server's new connection. So when it gets a new connection, it would then call the handle connection slot in your main GUI. And the following one would be item 5. Within that handle connection slot, you would call the listen method on your TPC server that sets your server running and tells it to start listening. So once you have a server that's listening, you would then go on to item 6. You assign a value to your TP socket by calling the next pending connection method on your server that you now have running. So now you have a working socket. We then look at item 1. We can then connect that socket. It has a ready read signal, and we connect that then to your main window GUI read message slot. And then the last thing we do in that read message slot, we will instantiate a qbyte array which is named data, and then call the read all method on the TPC socket, which is then read into your qbyte array. So my suggested answer would be 2, 3, 5, 6, 1, and 4. Just remember that in 2022, the assignment question was on TPC socket, which is why it's been asked in the exam paper. I think in 2023, your assignment questions was on UDP, so it's very unlikely that you will get an exam question on TCP. It's much more likely that the exam question will be on UDP in 2023, because they normally ask the questions based on the work that's been covered in assignments. That, guys, briefly, or an hour and 20 or so, is a quick look at the October-November 2022 past paper. I hope that is of use to you. Thank you.